Okay. Okay, in the meantime, it's starting on. Let's quickly start. Okay. Okay. So first of all,
Sahil, is there any way you can continue writing the notes in the same Hadoop class notes? Because I was trying to get into the age-based notes and it wasn't letting me get in. It's easier if you can do it on the same one you are continuing.
okay, so you're facing difficulty in opening it, or like it's giving you access denied?
I downloaded it and then the file was like corrupted. It didn't let me get this one. I couldn't open it.
Okay, let me check. Okay. Let me make it in a separate on my notepad, and I'll like write all of it, even the HBase part in the same all notes as well. Just do that first. it's responding very slowly today. I don't know everything. Probably it's network condition. Okay. Yeah, it's done on this for the HBase. Let's start with Spark. Yeah. Okay. So first of all, what was the need for having uh, let's say Spark first. Okay. Okay. So for traditional processing that we were using, uh, like yarn or anything like that, so we were mostly spending a lot of time, around 90% of the processing time in three things. There was disk IO, second one was streaming, and there's another third one. One second, guys. Yeah. Okay. Second one was replication. So when we used to write things in HDFS, it involved replication of that data. And last one is like streaming. Okay. So and how does how does it happen? So let's just think of an application that we are trying to submit. Okay. So let's say uh, this application reads some data from HDFS, and then it launches certain mappers. Let's say that uh, there's only two iteration in a normal. So this is all related to the normal frameworks where we are using mostly MapReduce. Okay, so we are using mostly MapReduce iterations. It could have been multiple iterations of map, and definitely lesser iterations as compared to map of reduce. Okay, so in our scenario, let's say we only have one iteration of map and one iteration of reduce. Okay, now let's say this job is reading some data and it's giving that data into a mapping stage, and this is being done from an HDFS read. Okay, now after this data is processed by mapper, there is an intermediate stage wherein the output from this mapping stage is written on the disk. And it's basically a HDFS write, so it's ultimately being written on the disk, right? So when it wrote that output of the intermediate mapper stage, it's being written on the disk, right? Now, once again, this data, let's say it's need to be processed by the other iteration, that is the reduction stage right now. So it's been again read by a reducer, and again, once the reducer is done with the action, it will again write that data back on the HDFS as the final result. And that's also being done on the disk, right? Okay, now you can see most of the step is of read, write, read, even in two stages wherein this is like a uh, minimum job stage. We have one mapper and one reducer. Even in that, we are like toggling, we are reading two times and writing two times from HDFS. And okay, let's just write it down. So we, in a minimal scenario, we need at least two HDFS read and two HDFS write. Also, so once you are writing it, there will be replication of that data too, right? So even in this intermittent data that's being produced, this is an intermittent, like temporary this is a temporary data that's of no use for us. It's just being used by the stages of the job, right? So even this data is being replicated with 3 blocks, right? So we are actually like replicating all of this as well as the final result. And since we are writing it on the disk, everything that you write in HDFS, it's ultimately being written on the disk of one of the data nodes, right? So we are also doing, in the process of replication as well as in the process of writing the data, it involved multiple disk input output operations. Also, to like be able to read serially and to be able to process that data, there is another step of serialization being done. Now, most of the time, and around 90% of the time within a job in a MapReduce framework that involves intermittent data write and read, it's the time is being utilized in all of this step only. Only 10% is the efficient processing time involved. Now, the idea was, when they were thinking of Spark, the idea was that I don't want to get into all of this stuff of reading writing. I would want to have a common distributed and this is like all being done on disk. I would prefer to have a common distributed data set or data object present in the memory. So always, so guys, whenever we talk of disk and memory by memory we mean RAM, and disk is by disk. Okay, so that's like a jargon. A common distributed data object should be present in the memory, and it's also should be shareable. So it's a shared object so that any processor that's being running on a different node can access this object. Also, it should prevent the overhead of multiple reads and writes of this data. Okay, so anything that's being read, starting from what's being read to what's being written to like or anything that's being done from the HDFS or data's point of view, it was thought of to have, instead of writing and reading it multiple times, having a common distributed data object that's transformed in between. So whenever it's being read first, there's an object that's created, and that object is called like an RDD. We'll understand what RDDs are. Once that object is read, and then it can be transformed. So whenever a job runs over that object or do something to bring out results out of that object, it can be transformed within the same object space that's being written into the RAM. And once that is processed, it's transformed. It can be, that's like HDFS write. And again, that transformation, that like if is being used by a reducer, it's again transformed and then written back, so on the same data set. So ultimately at the end what you get is a final version of that data set, and you have prevented yourself from the various multiple reads, writes, and back end, it's like the disk I use are also prevented. All right, now how does, apart from this, you have also utilized, so you are able to prevent disk IO, you are able to prevent a replication of this data. You're able to prevent serialization as well, because you're actually not synchronizing various data sets, but instead you're only working on a single, you're only transforming and working on a same data set. So you are able to prevent serialization. And another advantage that you get is that you are actually using a faster memory resource, which is actually the RAM of the cluster, to process out all of this. So ultimately, you are only working in a time zone that was actually the 10% of the normal framework. 10% time of the normal framework is the 100% time, approximately 100%. It's not like these things not doesn't like creating a RDD and performing an action over it and transforming it doesn't involve time, but approximately it's most of the time is like into the processing only, as we're just creating one object. So 10% of the normal framework's time is approximately 100% time utilized in Spark. All right. I think we have another very good explanation of this. Also, one more thing to understand, as it says that in here, so Spark it can be an independent tool as well. Okay, Spark can be independent from Hadoop. Hadoop for Spark is just it uses it for the resources only. Okay, so you can also create like a standalone Spark cluster wherein it's not using Hadoop as its intermediate resource framework, but it uses its own framework to manage. But mostly you would see Spark running over Hadoop because that's a little more economical, and it uses Hadoop. But when it uses Hadoop, it's just for the resources. That's actually the storage in terms of HDFS and the processing capability in distributing and the distributed processing. Okay, so Spark uses Hadoop in two ways. One is storage, second is processing. Since Spark has its own cluster management computation, mostly it uses Hadoop for storage. But in our case, instead of using the Spark's internal, we'll be actually using the Spark over Yarn. So you can say that the processing power of HDFS, or sorry, of Hadoop is also being used mostly by people who are using Spark these days. And it's when you say you're creating objects in memory, you say that you're actually doing in-memory computations within Spark. And again, memory here means RAM. So you're actually, everything is being computed in a faster memory, that's RAM. Okay, and that's why it's become faster. So Apache Spark is a lightning fast cluster computing designed for fast computation. Everything that you want to achieve at a faster rate, you have to involve RAM for that. And it extends the MapReduce model to efficiently use it for computation. And how does it extends it? It extends it in a way that the intermittent writes and reads of data is being replaced by just transforming one of the distributed data sets, and that's actually also written within the RAM. The main feature of Spark is its in-memory computation that increases the processing speed. Okay, a little introduction about the Spark is also like given So it was developed as a Hadoop's sub project. So like some of the people were working on Hadoop as majorly, while some were working as on this project. It was considered as a sub project, and I think in the year 2013 it was donated to Apache somewhere in you like Berkeley's. This was being done. All right, some
So,
features. Yeah.
uh, so when you talked about it could be used independently,
Hmm.
so can it be used without CDH deployment?
Yes,
You
yes,
mean that?
yes, yes. So you can create, you can create only Spark cluster wherein um, you give it instead of HDFS. So let's say you don't want to use any other processing, and you are fine with the Spark's internal computation and processing framework. In that case, you just need to provide it with some place where it can write the final data sets, right? So that could be your local file system as well. So even without CDH deployments as well, you can create a Spark cluster. Okay.
All right. So, yeah, thank you.
Okay. So here it says the speed, it's around 10 times faster, and that's exactly what we said in here. So 10% of the total of the normal framework's time is around 100%. So that's around 10 times the speed, right? We are actually working at 10 times faster than the normal MapReduce framework, and this is possible by reducing number of read writes. That's around 90% of a normal MapReduce processing, and that's basically being stored on the intermediate data is being stored in the over here. The memory means disk. Okay, it supports multiple language, although that's being supported, and that's like these languages are like Java, Scala, or Python. So you can write applications in any of these languages, and it also helps you if you are doing some advanced analytics. So most of these days, a lot of people are interested in concepts like machine learning, artificial intelligence, and streaming data. So let's say you're getting some data in a continuous fashion. So streaming data processing, and you want to process over it and return the results. And graph algorithms. So graph algorithms, you can think it of you know representing your data in a graphical manner. The results should be like in a graphical representation of that data. So that kind of processing. So all of these kind of processing, these are not supported by uh, the traditional uh, uh, computation, because these requires advanced analytics as well as little faster computational speeds. When you're talking of something like artificial intelligence, wherein the tool that you create, it has to artificially think of how one should react in a situation, and then process that immediately. So that's required a little faster approach of processing the data. So these kind of tools and frameworks which were introduced, which are being like a lot popular these days, they can be worked upon with Spark easily, and you have separate libraries that Spark provides to deal with all of them, and we'll see that in a little bit of time. Right? Okay, so these are like the three kinds of scenarios or deployments. One is standalone. So in this standalone, It just uses Hadoop's HDFS for storage, while the processing and the computation, it's internal to Spark only. Over here, you could have replaced this HDFS and Hadoop with local file system or some other storage framework, and that's how you can create a cluster without having a CDH deployment, where it just needs something where it can store that data, and that's why it's called standalone. But yes, when you're talking of a CDH deployment cluster, standalone would mean that you're not using any of your computational frameworks like MapReduce or Yarn. Second one is like an older version, which is like Spark 1, I guess, that uses MapReduce framework. So here MapReduce like refers to the Hadoop 1 MapReduce, Hadoop version 1, and then you don't used to have Yarn. So if that is being used for computation, along with the storage. So storage will always be used in like all of these three deployments, along with the storage of Hadoop. Third one is where it uses Yarn for processing, that you would find in like the version that we are currently using, and like most of the companies are over. Like you will really find Hadoop on any deployments that use Hadoop 1. So that's like Hadoop version 2. It's little like Mesos also here, so you can leave it for now. You can think it of like using these Yarn. Okay, so it says in standalone, it just occupies the place on top of HDFS just to write uh, its data over it. Then on Yarn, it runs Yarn. Okay, it helps to integrate Spark into Hadoop. So that's like a little information that we don't need right now. That's being shared in here. Okay. Okay. Now let us talk about, these are the like three deployments. Let us talk about what are the various libraries that Spark. Okay, so guys, all of these libraries, none of these will be used by you. Okay, these are all like developers' point of view. They need to understand like about these libraries. But okay, it's fine to know about that, so that when you get into troubleshooting, you at least understand, okay, out of what all these four that the job is referring to. Okay, so that's just for understanding as an admin's point of view. If you're interested in development as well, you can elaborate these libraries more. Okay, libraries that Spark uses. So we have Spark SQL, we have Spark mlib, uh, Spark streaming, and graphics, and they all are sitting over
Sahil, these are basically the Spark APIs, right?
Yes, yes. These are Spark APIs or libraries, you can say. They are like separate. So it's also written in Java. Like mostly Spark is written in Java, so you can think it of as packages or APIs. They're all sitting over the Spark core. Or the Apache Spark core. So this is the core is like the you can think it of it as the underlying framework which all of these libraries actually uses, and that's basically Apache core is like an integration with your either your HDFS like also for storage, and if you're not using the internal computation, it's an integration with the underlying framework, computation framework like Yarn or Mesos or MapReduce. And Apache Spark Core has those libraries that integrate it. Okay, so when you integration with HDFS, Yarn, or MR, all the libraries that are involved in this part, that's basically it's a job of Spark Core. Okay, and the integration of all of these libraries at the other end is also a responsibility of Spark core. So you have the major part of Spark deployment is basically the Spark core, and then you can, depending upon your need, you have all of these four kind of libraries that you can import while writing a job, writing like creating a Spark a job. You can import it and then use it. Okay. So it says Spark Core is the underlying general execution engine for Spark platform that all other functionalities built upon. Mostly that's the functionality is like in memory computing and then as well as uh, integration with external storages. That's basically HDFS in our case. Then you have Spark SQL on the other end, and as the name suggests, so if the similar way how you tend to use Hive or Impala to run SQL-like queries over HDFS, you could also use Spark SQL as an alternative to that. While Hive, we all know Hive internally uses MapReduce to run a query. Over Spark SQL, you can replace that MapReduce with the data sets or RDDs uh, to carry out similar uh, computation. So if I would give you an example of how this happens, so the similar query like select star if you want to run over Spark SQL, you would have to do something like an import. And this import is basically a statement of PySpark. So there is there are various kind of tools that Spark provides a developer wherein they can write their code. This PySpark is written in Python, and let's say you want to run a Spark SQL, so you can import something like Spark SQL project. I don't exactly know the name know the name of that package. So it's something like let's say Spark SQL. After that, you create an object let's say of a hive table over which you want to run this. So you create an object or an RDD by referencing a table. It's something like sq.table, I guess, right? Wherein, let's say, you provide the table name as database dot table name. After that, you uses this package of Spark SQL again to, I don't know, what is that method name? So there's some method involved wherein within that method you provide your query. Either you can provide your query, or since we have already loaded that table, so we could have done something like this object dot filter, so that select star from the table where the where clause is actually being replaced by a filter clause within Spark. So this is all how Spark would actually replace that normal select star query, select star from table query. And this is all being done using data sets and in-memory computation. So it's even faster to get results than how you would have get it either in Spark or even in Impala. Although Impala is like easily accessible tool, because you don't need to do such kind of imports and stuff to use Impala. You can directly run a query over Impala. But when you are actually writing a job, or a job or code, so over there within Spark itself, so over there, either instead of referencing Impala, even if wherein you open Impala shell, run a query and get the results, you could have done it even faster. You can have prevented this extra uh, what do you say, this extra overhead of creating a connection to Impala, running a query and getting the results. And that also too might involve a little map reduce at the back end. You have completely replaced it using this package of Spark SQL. And this is like very most of the time, organizations which are not over machine learning or graphical representation, they tend to use, like, most of the time you'll see Spark using SQL being used when you could hear words wherein people say like persist or cache. These are like things which most of the developers would to want to. So in the intermittent result, they want to persist it. They want to let it be permanently available, and most of the time it causes overhead. These two things, they tends to cause the admins overhead of memory.
Can you explain a little more on cache?
Yeah. So as an admin, these two things causes memory overhead. Okay, so cache, when you talk of, let's say you created an RDD, although we haven't reached RDD yet. Okay, so let's say you created an RDD object, the similar object that's basically related to the table. Let's say this RDD is the same object X. Okay, and after that, what you did was you transformed it. So when I say transformed it, I actually ran some filter condition, some where clause. So just like you have a select star from table where, let's say, ID is equals to Sahil. So that where clause, whenever you run it with the next filter statement, something like that, you actually transform that RDD into something else. But the value, let's say we are already storing it. So let's say we are using another variable to store this value into, and we have transformed it into V. And finally, we are using this transformation uh, to run another transformation over the same. So intermittent transformations, most of the time, if they're being not being stored in a variable, although we stored it in a variable, let's say we haven't stored it within a variable. So these, they gets overwritten, right? So whenever you do another transformation over it, when you do another transformation over it, it's actually uh, being overwritten. This thing gets overwritten with the next transformation. To be able to access this intermittent transformation in future as a reference, what they generally tend to do is they cache it. So you can do, once you have done this transformation, you could have an intermittent stage of caching, so that in future, when you want to revisit this transformation, when the developer wants to do this transformation again, that would cause him a little less speed, also a little less time, because that's already being cached by his application somewhere in memory. Caching is also in memory. So what happens in caching, as why do I say that it causes a memory overhead? So apart from the normal in-memory computation that's being done in the transformation, you have an extra overhead of storing the cached information as well in the memory. So that's tend to use a little more RAM as compared to what could have been used within the job. So that's why caching calls can cause a memory overhead to the admins. So most of the time, whenever somebody says, okay, so let's say you get a job issue where the developer says I'm getting out of memory or memory bound, uh, memory overhead exception. So most of the time, what we ask them is, okay, have you used cache, or are you persisting the data within Spark? Uh, if he says yes, we generally, as a first round of troubleshooting, we say in those cases that please try to use it without caching, because you tend to give a little limited RAM for them to utilize for their jobs, and sometimes when they cache, their actual requirement becomes more than what you actually allocated them in the initial phase. So to prevent them, you tend to call them to remove those lines where they're using caching or persisting the data sets. So that's like all associated with how developers can fine tune their job, uh, and how much resources the admins can actually provide them. So you have to like collaborate with them and come to a negotiable state. Okay. So this was about Spark SQL. Similarly, you have something like Spark mlib, Spark streaming APIs, or GraphX, which gives you another imports, some other frameworks wherein you can utilize them. Mlib is, if you see the data scientists, people who are working in your organization, you would see that mostly they're using mlibs, GraphX, or some other external uh, frameworks as well. So mlibs are distributed machine learning uh, done by the mlib developers against the alternate. So these are like something that's part of the machine learning environment. Okay, and similarly, you have a graph processing framework wherein you can actually process that data into graphical interfaces. Although, I again repeat, it's all the headache of a developer. Okay, now comes the actual object that Spark would reference all the time. is actually called or an RDD. I think for RDD, Edroy cast tutorial is little better up till okay, we did about this core spin machine lab. They even say that there is something like Spark R. So these is like an ever evolving framework. So we have something like Spark R for that matches up with the R repository. R is also used by data scientists mostly. Okay. Right. So how do you name it RDD? So that's exactly what it means. All right. So it's resilient because it's fault tolerant and capable of rebuilding data on failure. So let's say in between any of these data gets corrupted, although it won't be a case if this RDD gets corrupted, you can again rebuild it by running the same kind of statement and again creating it. That's how it's become resilient. It's distributed because the object that's actually being created at this step of creation of RDD, it's actually a distributed in-memory object or distributed object that is stored in RAM. And by distribution, it actually means that it's being shared among the multiple nodes within the cluster. Finally, why it's called a data set and not just data, because within it's actually a partitioned data with values. So whenever you load it, you're actually creating a partitioned scenario like you see in here. So if this is an RDD3, within this RDD you have multiple such partitions which are actually distributed among multiple nodes within the cluster. And yeah, so this is a little concepts that's very important to understand, which is lazy transformation that's being used by an RDD. What does it mean? So when you say lazy transformation, what happens is actually when you create a RDD, immediately it doesn't get stored. Doesn't get stored in RAM. But instead of it, it will get stored in RAM only when you run an action or a transformation of this data set. So immediately when you create an RDD, you are just creating a configuration for it. And it doesn't get stored in RAM, but instead when you do some action or a transformation of this RDD, then comes a time where the real RAM is allocated. to the object. And this whole phenomena is known as a lazy transformation. That's very intelligent, because that's how you're actually intelligent in a way that you are optimizing the use of RAM as well, right? So you are intelligently optimizing your use of RAM in parallel to using same RAM for in-memory computation, and that's also what Spark tends to utilize. It's like, this Spark is mostly preferred. It's a mostly preferred tool. Most of the developers tends to write their code over Spark, because you can see how much intelligent this tool has evolved itself into. It makes them run it in a easier and faster way. Okay, now it says you might be wondering about its working. Well, data in RDD is split into chunks based on keys. There's little more insight into the RDD part.
Go over the lazy transformation one more time.
Okay.
So it basically it creates an action, but until it does the action, it just stays there.
No. So let's say, let me give you an example. So there are various phases first of all, for an RDD. Okay, RDD has few phases. One is creation, which leads to transformation whenever you run an action over it. I think they must be present with this tutorial as well, these phases. Let me check. Create, transform, and the other one is like persist, I guess. Let me just verify that. I think this is a very good example that also involves caching in between. Okay, let's just verify. Let's just take a look over this. Okay, let's say there was some text file, input.txt, that was present. So this particular step, where let's say you are using a Spark shell. Okay, so the first stage is creation. At this instance of time, memory is not allocated. You are actually not, memory in RAM is not allocated. Okay, now when you perform a transformation of this, and how do you perform a transformation, which is the next step? Creation, after that you have transformation. Let's say the aim, he says over here that the aim is to count the words in this file. So it will create a flat map. First of all, it will split it, and that mapping, map it in terms of the spaces between the words. Definitely within any file, the words are separated by spaces. So that's why it's splitting over this object with spaces, and finally it will be using this reduce by key with a plus sign to compute the final count of that file. So this is like a complete statement where it's performing the actual transformation. So final value of that it's creating as an RDD again is known as counts, wherein it's using the input file to run a flat map function, wherein within the flat map what it's doing is each line of this file is being splitted into various objects depending upon the space character within them, and then it's creating an internal word. So any object within this line is actually a word for it, and for all of this word it's giving a value 1 to it. Okay, so within this line of the file, within this files, each line, it is actually splitting it into words depending upon the space character, and then each word is mapping it to a value 1, and finally it's using a reduce by key to add all those ones for each words and then finally return an output. You can see it's actually a MapReduce framework that's being employed in here for the transformation of this input file. So when I say transformation, you're actually creating a new object out of the previous one after running certain functions over it. Okay. Now at this stage is where it's actually a lazily transformation. Okay. Initially when you created it, you hadn't involved the memory. But when you perform a transformation over this object, that's actually when even this part is being, first of all, this thing is being involved and its memory is allocated to it. Then you run a function over that memory. Within the memory, you run various functions so that you can finally compute an output. And once that's done, even this counts, it's like you are creating a count variable in here, but it's also like a separate object. And this is how, this is all like a lazily transformation, because whenever
Until getting the final result, whatever results that steps we are going through, all of these are calling as a lazy transformation. So basically they're not actual transformation, they have steps.
so yeah
That's what exactly it is.
no, so what you can say is, if it hadn't been lazy transformation, if it hadn't been a lazily or intelligent transformation, what would have happened? So in that case, even in the creation step, you would have allocated, let's say this object requires 2 megabytes of memory. This file is enough that to create 2 MB of RAM, right? So even at this step, I would have allocated out of my complete share of RAM within the cluster, I would have allocated 2 MB RAM to this object. And now again at this step, it would have done some computation and required certain memory. Let's say that is 4 MB. Okay, so in all, these two steps without lazy transformation, so although we cannot compare it in this way, but let's say in all it required 6 megabytes of RAM, right? But when I did a lazy transformation, instead of allocating this 2 MB RAM right away at step of creation, I give it nothing at this point. I only uses this 4 MB, and within this 4 MB of RAM, it includes certain memory of loading. So this step of loading this object within the RAM is also being included in the transformation part, and it actually tends to utilize less memory. You can say, although it's not like a right comparison, but yes, it tends to utilize less memory as compared to what it would have done without a lazy transformation. So lazy over here means that the framework is lazy enough. It will only call RAM when it feels that something, it's like transformation is trying to perform over an object. Otherwise it will sit idle without having the memory, but just the configurations that would be required for it. So that's how you tend to actually, so instead of straight away allocating the memory, you have that memory with you to be used by some other code or some other job until and unless this object
Basically,
requires.
the benefit of using lazy transformation is saving the memory.
Yeah, saving the memory as well as uh, so how do
Not
you
using unnecessary
optimize? Let's
memory.
say you're saying optimizing your complete utilization. Saving is
Okay.
not the right jargon here. You can say you're actually optimizing your complete cluster utilization. Instead of right away allocating certain resources to somebody, you are only allocating a resource to somebody when he needs it, and up till that point you have that resource to be available to some other job, right? So you're actually optimizing your complete cluster utilization. And this is something which is not controlled by us. Admins doesn't control this lazy. This is like an inbuilt thing for Spark. So whosoever was designing it, he thought it in a way that, okay, although I'm using RAM, to optimize my RAM usage, I must use something like a lazy transformation. So whenever you run it, you're actually calling the RAM over it. Now you can see somebody was asking about cache. So this is a method that he used to cache this count. So whenever he was able to create, he said like you can mark an RDD to be persisted using the persist or cache. Most of these object methods tends to work in the same way. The first time it is computed in an action, it will be kept in memory on the nodes. Use the following command to store the intermediate transformations in memory. So whatever intermediate things that were done within this count object, whenever you run a cache method over it, it gets to store within the memory. So when if somebody is using this cache, let's say after this point, let's say he's trying to cache it with this method, this would require some more memory is required, because all this intermediate stuff would otherwise would have been washed away by the framework. And finally, when you want to store it as an output of file, you could have run like this. So these are all like methods that Spark provides us. Okay, they are all inbuilt methods for transformation, creation. So over here, since we were referring a text file, there was something like text. If you would have been referring it from a Hive table, you could have used the Spark SQL. SC over here refers to Spark context. It's basically the object that whenever you initiate a Spark tool, you tends to get an application that's being referenced by a Spark context. So you could have a text file object to import some text file, or you could have a table object to when you want to load a table. And similarly, you have certain more kind of like intermediate uh, methods to perform transformation, cache, and finally loading those into the output. Okay, so we came to understand this point. Okay, so we were talking about lazy transformation. Right? So this is how you can think of the lazy transformation to work. Okay, a little introduction about lazy, I think. And in here, RDDs are highly resilient. They are able to recover quickly, replicated across multiple nodes, even if one executor fails. Okay, before going into this executor and stuff, so this output step is actually an action in here. This is optional step. As I told you, most of this people tend to use it optionally, but the major phases is creation, transformation, and action. Cache or persist, you can say. Okay, so before getting into the Spark architecture, let's just quickly install Spark. So up till now, whatever we discuss, it's like understanding of the core of Spark. Why do we need it? How does it helps to give you intelligence? So these were like the benefits, and you could have included two more points in here. One which we just now discussed. So lazy evaluation, and another point which you might have observed is lesser lines of code. So something like a map reduce. In a single line, I was able to create a mapper over here and a reducer. But if this would have been done over a normal Java, so although this is a Python thing, or sorry, a Spark context thing, but if this would have been required to be done on normal Java, right? You would have to write a separate mapping function, a separate reducer function that would involve multiple lines of code. But what you have done is you have actually replaced all those multiple lines with a single line. So that's also a little advantages to developers, lesser line of codes, reap to reap similar results. Let me just save this file first. Okay. Okay. I don't think Spark is here. No. Let's just add Spark. This is my single node cluster. Any doubts up till here, guys? Apart from Samia, what about others? Are you getting things or still it's hazy? Fahim, Ratan?
Sahil, for each,
Mm-hmm.
we did the loading, right, by ourselves, but there is nothing else to learn in there, right, for each base?
Okay, so for HBase, it was the introduction, loading of data and then scanning and then running get. Those are all they might be required by you, and there are certain other kind of what do you say, methods also involved in HBase. But mostly what you will be interested is in HBase HBCK. Okay, so you could have tried to run HBase HBCK and try to read all the outputs. So all these troubleshooting kind of scenarios you might get into. So you might require to run something like get scan, because most of the time what happens is when someone one is not able to access a particular HBase object, let's say, so it tells you to debug it. So what you'll do is you'll come back to your HBase shell. Most of the time, even when HBase shell doesn't tends to open up with something with the architecture, either the master is down or something like that. If the master is working fine and if everything is fine, then you tend to run something like scan or get over it and see whether you are able to fetch the data yourself or not. If even that works fine, uh, you know, most of the time it's something with the developers end. Otherwise, you could use HBase, HBCK, which is the file system check that we discussed, right? I don't know if I showed you how to run that HBCK. So it's something like whenever you run it, at the end it gives you whether the state of the cluster is consistent or not, whether it's inconsistent or not. If it's inconsistent, you tends to have I think I did discuss that, right? So you tend to have multiple options that HBCK provides. Let's check this in notes. So mostly whatever we discuss, that's enough for anyone to troubleshoot. So whenever I discuss any service, right, it's from the perspective of the issues that you might get into and how you debug it. So when you did the creation of table, you actually knew what could have be the syntax of when somebody would have been created a table. Then when you did a loading of data, you would understand how actually when you do an ETL, extract, transform, and load within the cluster. Let's say you're loading it into HBase. So how actually exactly you are able to load that data. Then when you run, when you did scan and get, you actually understood how you actually can fetch that data out of those tables. No, so most of the time, this is what is being done by a developer. But why do you require it? So that when you're troubleshooting it, these are the first initial steps. Then we discussed about HPCK. That tells you when all of this fails, when you're not able to access the outputs, you could actually run this tool, file system check tool, to finally understand the state of your cluster is into. Also, we discussed about granting permissions. This will also be like mostly used wherein you are trying to grant permissions. And then we talked about HBase.
Also,
Yeah.
you wrote here the git command. It's supposed to be other way around. The table name should be first and then the row key.
I don't think I wrote get.
I think it's for number 5.
I think it's okay, yeah, right. So I think it's table. You're saying the table should be first, right? Yes. So table followed by the row key. Right. And then I talked of HPCK. So did you try running HPCK on your clusters?
Tried it.
Okay. So when we'll be discussing troubleshooting scenarios, I'll create a scenario wherein the table is inconsistent, and in that case you could have used any of these options. So we'll see. Mostly you'll get options like a whole or assignments. So you have something like fixed assignment. There's something like HDFS holes. Holes is like in little inconsistencies in terms of how data is stored on the HDFS for HBase. So it tends to create holes. So you have something like fix holes, or there could be something related to the splitting pattern. So all of this, is required. It can be used, and the master of all of these steps is this repair command. If you just write hbase hbck space hyphen repair, it's a shortcut for various things like fix assignment, meta, holes, orphans, overlaps, version. So all these kind of issues can be fixed by just running a repair command. So we'll discuss, like we'll see within the troubleshooting case how what kind of issues we can get into and how we can use it, these kind of steps to fix that. So it's fine to understand the scan, load, and the creation part, and other things are as far as admin you can understand as and when you get into the issues. Okay, any other question? What about others?
Yes.
Who's this?
Yes, Shahir Ali. I'd like to ask this, can you explain more about the lazy evaluation?
Okay, what exactly you didn't understand in it?
Lazy evaluation.
Yes, so what in lazy evaluation? I will just read that one.
Lazy transformation, I guess.
It's fine, lazy evaluation or transformation. So what exactly don't you understand? Okay, just you try to explain to me whatever you understand about lazy, then I'll explain more. One second. Okay, to let's like summarize it again. Uh, let's say you want let's say you want to run a query. Okay, you want to run this query using Spark SQL. Now, what are the things you need? First thing is you need to create an object of this table. Okay. Second thing is you need to run a transformation. And when I say transformation, you're actually using the where clause at this step. Where clause wherein you filter data where id is equal to my name, and finally you will write this output. Okay, so these are the three steps involved, right? Now let's say there's somebody else also who's running some other query from some other table, T2. I think let's just say that he's trying to do this. Now what all steps will this be required in here? First of all is object 42, then fetching of results, and finally writing. Okay, now assume I have 4 megabytes of RAM only. 4 megabytes of RAM. Now this complete scenario this whole thing requires, let's say, 3 megabytes. While this whole things requires, let's say, complete 4 megabytes of RAM. Also, let's say the first step of this object, the first step of this query, I ran it 4 MB is complete RAM. Okay, so don't confuse it with anything else. It's the complete RAM. Let's say this first step I ran it at 9 a.m. and I plan to run the second and the third step, let's say at 1 p.m. 1 p.m. in the afternoon, and finally I want to write this third step at 4 p.m. in the evening. But this guy, he's very quick. He just wants the results very quickly, and he runs it. The second step at, let's say, 10 a.m. He wants to fetch the results within 15 minutes, so he'll run the second step. Like this, he's continuously running all the three steps, at 10 a.m. Now, if it would have been a non-lazy transformation, if my framework was not lazy, okay, what the framework would have done? At this step only, he would have allocated 3 megabytes of memory out of my 4 megabytes in the cluster to step 1, right? Who was the guy who had the issue? Alim? You able to understand this, right? Are you able to
Yeah,
understand
thank you.
what's my need is?
Yeah.
Okay. So my need was to
Mm.
run these two queries, and at 9 a.m. this guy created an object. If it was not lazy, what was not lazy? My framework. If my framework was
Mm.
not lazy, he would have given 3 MB out of those 4 MB at this step. And when at 10 a.m. this guy came and wanted to run a query, he required 4 megabytes of memory. Would he would have been able to get that memory? No, right?
For
Because out of the 4, 3 is already utilized. He is only left with 1,
one is it?
and he was
One.
not able to run his query at 10 a.m. That's why the thinkers of Spark, they made it lazy. They said, okay, so I won't, allocate you memory until you run something over that. So I will, according to them, they will allocate memory of 3 megabytes only at 1 p.m. when he is actually performing a transformation, and also at 4 p.m. when he is trying to run. So this 3 megabytes will only be utilized at 1 p.m. And this lazy evaluation, this lazy transformation actually
Transformation.
help
Mm.
my people to optimize the 4 megabytes of RAM, and he was able to run it at 10 a.m. This is what is
Same time.
lazy. Okay, now is it clear?
Yeah.
Read more about it.
Yeah.
Okay, to make yourself more understand, like how exactly it happens, uh, what are the steps involved within Spark to make this happen. Just read a little more about it and it will be more clear. Okay.
Thank you. Thank you.
Okay. Any other questions? I think for today we are running out of time. We might just add Spark for now in our cluster and discuss more of it later. Any other questions, guys? Apart from it, let's just quickly add Spark in parallel. Okay, you see there are two options in here, right? One is Spark standalone. You can see this is a standalone version of Service which does not use Yarn for resource management. Cloudera recommends using Spark on Yarn, although. So if since you're already using Yarn in the cluster, why do you want to go for Spark standalone? This is basically used with the deployments where you don't have a CDH cluster and you've just imported Spark libraries. So we'll be going ahead with Spark on Yarn. And It would require HDFS to store data. Since we are using Yarn, it would require Zookeeper to manage the states of HDFS in Yarn. So we'll be going with first one. I don't want you to use HBase with Spark for now, because I don't want you to be confused about how that's being used. But yes, you can evaluate your HBase tables also using this. Okay, the role involves are a history server and a gateway. Gateway is nothing but a client of Spark. Whenever you want to execute a job, you can use this gateway. So right now, since we have only one node, history server is used to store the historical applications. Apart from that, you can see you don't have any other role of Spark, because it's actually using Yarn for the service roles. It will be using the Yarns, containers, node managers to launch its executors and stuff. And this service, as you talk of, it only has one role, which is storing all the applications which were run on the cluster. Let's leave it default. All right. Okay, in the meantime, when it's starting, let's just check what are we left with. Okay, so I think we are left with a little bit about the architecture more. How does it runs a job, on the cluster? What are the steps? And the Spark shell, let me just show you right now. How do you open a Spark shell? And yeah, let's just open a Spark shell and try to run this same RDD for now, all these steps. And let's just check what all troubleshooting from the admin's point of view, what all you can do. In the next 10 minutes, we'll quickly try to do that, and we'll try to understand what exactly happens in between. What are the architectural steps which are used? What is this? What is a driver? What is a DAG? What are the executors? All of that stuff we'll just I think discuss in the next class. For now, let's just quickly launch Spark Shell. Once it starts, while it's starting, let me connect to my node. All right. Okay. Spark is installed. Let me quickly check if my history server is working fine. This is the Spark history server. Let me open it. So you won't see, apart from history server, anything available, because since we are using it over the Yarn, everything is being handled by Yarn. Okay. Since we don't have any applications running for now, it's fine. It's not showing. Okay. So how you used to interact with HBase? Similarly, you have various tools to interact with Spark to run a, actually launch a job over Spark. One is a PySpark. Then you have Spark Shell. PySpark, it's basically a Python tool to interact with the Spark. Spark Shell, it's a Scala tool. Scala is a language. Python, Scala, Java. So anything that relates with Scala or Java, you would have to by line if you want to do it. So these are all interpreting tools. You have to for each line you have to write a code and run it. So Spark Shell is basically for Scala and Java. Then you have Spark Submit, in which you actually tends to provide code, application code to run instead of opening an interactive shell. So these two are like interactive shells. These two are interactive shells, while this is not an interactive shell, it's a submission. Submission mode to run a job. Okay, so let's just quickly open one of them, which is Spark Shell. Whenever you will have open a tool like this, it's actually able to launch. It will be launching a application on Yarn. Now it's failing right now, you can see. So this is the problem of admin. Although we were going to solve or to do something like a developer, but we went into a problem of an admin. So can anybody explain me what exactly is wrong in here by reading this error? Just read about this error and tell me what is wrong. But before that, let's just check if anything else is not wrong. Okay, apart from that,
There is one warning there in the cluster I saw.
Okay,
down below.
Okay, forget that. Just read these 3 lines and tell me what is wrong.
It's on safe mode, I think.
Not able to see? Okay, one second. Let me just copy it.
I think it's a safe. I think it's on a safe mode or something. Because
I
it's
think
talking about
some threshold limit is crossing, something like that.
Okay, which threshold? Threshold of what?
It says about
memory.
threshold
Memory.
0.24.
Right. So it's like very clear, you know. Okay. Is it clear now? Is it like, are you able to see this now? Everyone? Let me make it a little more.
Oh yeah, I think the memory is exiting the limit.
Alim, Fahim, what do you see? What exactly could be the problem?
Yeah, I told you the limit, threshold limit. There's the memory.
Memory, yeah. Threshold.
Executed memory.
Memory.
Okay, nobody else will speak now. Fahim, what should I do? What is he saying me to do?
We have to go to the configuration, then increase the memory threshold, the executed memory.
Okay, Fahim, now you speak.
And
Sarah, you there? Nikhil, Sarah?
Yeah, I'm here.
Okay, what exactly should I do? Like, how do I change that threshold?
You have to increase the memory.
Which memory? What's the property name? Like, if you see that.
The resource memory of the Yarn node manager.
Right. So what should I do with it? Should I increase it or what?
You should increase, yeah.
Okay. Anybody else? So let me tell you, I have one node. Okay. I have one node with limited memory. And by default, it's saying it requires at least 1024 plus 384. How do I see that?
Can you add other nodes to it? If you add like 3 nodes to it, then it will distribute to another
Okay,
node.
let's say I don't want to add 3 nodes. Then what should I do? How do I solve this problem? My company only gave me one node. How do I solve it with one node? So, okay. So one point I think you're clear is it says, please check the values of these two properties. Okay. Now, should I increase its value? First of all, what should be the default value? What do you think would be the default value? It's very clear, guys. He says,
Default value is 1024 is the default value, right?
right.
One.
So let's just quickly check this property and see. So instead of increasing this value, I will decrease it for now, right?
So
I would decrease this value because I don't want to add anything new. And these two are properties of yarn, mind you, okay? These are yarn properties. So we'll, instead of checking it in Spark, I would have to go to yarn. Is the screen lagging?
We think we should stay on 1025 megabyte, right?
So no, currently it's 1024, but the Spark requires it to be a little more. Okay, the Spark requires a little more than 1024. It requires around 384 MB more than that. So he's saying me to, he's saying in this error, required executor memory is this, which is above the threshold of the cluster. Please check the values of these two. But I don't think I might be able to increase that. But let's just check that first. If it's working fine when increasing it, although I think I have 4 GB. So I think yes.
But it could be any of these two.
Yes, it could be
Any of these two property.
It could be even both of them. Let's check it first.
Oh, okay.
So yeah, that's right. We might have to increase its value in this case. But what my point was, let's say I don't have this much of memory, how would you solve it in that case? So I would have to fine tune my Spark executor memory as well in that case. So we'll check like where we can find this particular properties value. In that scenario, I would have to reduce this value so that it doesn't need more than 1024. It's something like Spark executor. But first of all, let's check these two properties. Right, you can see it's 1 GB. I checked it for 1024 MB is nothing but 1 GB, right? So this property is also 1 GB. I think this is, it says and or, so it could be even both of them. And this is also 1 GB. So what we'll do is, let's just make it exactly how much it needs. It needs around 1500 MB. This one and this one too. We'll save the changes. It requires a restart. No, mind you, it's requiring a restart. So when you're doing it on a production, you have to take a downtime, because whenever you restart, all the applications that's running for at the moment, they will stop, and you might end up getting multiple notifications from various of your clients that they were trying to run a job, it failed. So you'll have to, intimate them before you are going to restart it. So all of these kind of configurations, when it's about in a production environment, there are certain steps. There's something called as a change request that needs to be opened. A time needs to be allocated. So, the admins has to be very, like, uh, what do you say, to the point in their work, so that, you only tend to get around half an hour or 2 hours to, at the, on a particular day to do such changes. So you'll have to be very sure, which all properties are to be shared, whether those properties will work after you change them or not. So that requires a little bit of experience with it. Okay, let's just start and we'll again.
Can we try PySpark there?
Hmm?
PySpark that you showed.
Yes, I'll try to show
instead of
you. I'll try to open the PySpark shell as well. Okay, let's just let this memory be increased first. Okay, as a homework for you, just try to figure out how can you reduce this minimum. So by default, the executor requires 1024 plus 384 MB, right? I right now, to make it a little faster, increase this memory so that it can be, able to use that. For a homework, I would say you don't increase this memory, but figure out a way how you can reduce this memory instead. Or is it possible, or is it not possible? So that's a research point as a homework for everyone. Okay, so you will be installing Spark within your clusters, and you might end up, although I think you might have 3 nodes, but still you might end up into this kind of problem. So instead of increasing this memory, figure out if it's possible to reduce the executor memory. I think it's
Is there
possible.
any way you can
Mhm.
no, never mind.
No, just go ahead, say.
No, I was just like, it didn't make no sense.
Okay, so let's try and launch Spark Shell again. So it's actually launching a yarn job at the backend, a yarn application. If I try to open the yarn UI, you can see application type Spark, which is launched right now. It's currently in accepted state. I think because of the node, maybe. Mhm. Okay, this app is still pending. Something it's not able to get even this 1.46 GB of memory out of that node. It might end up taking a lot of time. Okay, let's just leave it up till this point right now. Let me also try to. So the point to be understood in here is every time somebody launches a Spark job, you're actually launching an application on Yarn like this. Okay, so the troubleshooting tends to remain a little same how you troubleshoot the earlier applications in that were launched in Yarn. Also, there will be another history server UI which will be launched. It was just like this. So this application will also start appearing in this particular UI. It has something like a little more information in terms of what exactly is happening within the Spark that you might see on this page. Okay. So troubleshooting is an additional step in Spark, is that you have to not just troubleshoot on the Yarn application UI page, but also you would have to troubleshoot it on the Spark history server, and rest like remains same. Everything like logs and stuff, it remains same. I think it's since it's a little less configuration cluster, it's still not able to get that one for 1.48 GB or 1500 megabytes of RAM out of my node. That's why it's still in accepted state. I think we can launch it in the next class over our 3-node cluster as well. Also, let me show you PySpark shell. So that's also trying to launch, although this might have been killed. Application had been killed because I killed it myself. Okay, it's still accepted because I think although we exited the shell, but the application is still present at the back end. But I think for PySpark shell also, it might have launched another application. Right. So now this 02 that you see in here, it's for the PySpark shell. You can see the name of the application is PySpark shell, application type Spark, launched with user HDFS, and it's also in accepted state, and that's fine because it's not able to fetch. But one thing that you can see in both of these shells, right? You can see something in Spark shell. It says using Scala version 2. So anything that you want to run as the language as Scala, then you might use Spark shell. But in here, when you're launching a PySpark, you can see it says Python 2.7.5. So anything you want to run using Python over Spark, you would always launch using a PySpark shell. But then when I was talking about Spark Summit, so Spark Summit doesn't actually launch as a shell. It's a tool through which you can launch a .jar, or let's say a Python file, .py file, something like that. So if you open a Spark Summit, it will actually give you all the tools that you might require to run a job. While those two earlier that we talked of were basically the shells. Okay, so homework for you is to figure out if you can reduce this memory instead of increasing. These two, can we reduce this? Second homework, launch a Spark shell and okay, so you would have to create a file first with certain words. You can download any other file from internet also. Certain words. Okay. Create a file on your local system. Then step 2 will be launching a Spark shell. And then step 3 is in you have to count the words within this file using Spark shell. Okay, this is the same example that we have discussed in here. So all those steps. So once you open the Spark shell, you will run this this step. Then you will run the second. Then you will write it as an output file like this. Okay. Although this all will be saved in HDFS, you will have to figure out where exactly it's being stored. Okay, so you'll have to do this also. Also, try yourself, although I am not sure if you would be able to do that. Open a PySpark shell as well and find a way to count the words in same file over PySpark. But I will leave this third as an optional case because I don't want you to get into the much of development stuff. This much of it is fine to understand because once you are able to do it, you would end up into the troubleshooting that's like which we are more interested into. Okay, so once you have done this second step, figure out as a third step, you need to figure out the application launched in step 2 and check the history server UI for what new you see. Finally, what you would need to submit me as a screenshot. So I want a screenshot for the final file, output file. As well as the last step that you see on the shell, on Spark shell. So screenshot of that, as well as the screenshot of history server UI for the same application. Okay, so these 3 screenshots you will be sharing with me. while in the next class, I'll also open like these shells on my 3-node cluster, and I'll try to show you, history server UI and what all is involved. But in the meantime, you can research about it yourself. All right, I think we can leave it for now. Any questions?
So can you send this one as a class, all class note? This one.
Yes, I am going to. Okay, let's just share it in the same all notes. Okay, so I have saved it into the same all notes. I'll also upload as a separate file. Any other questions, guys, apart from it?
No questions, thank you.
Okay. All right, so I've uploaded the separate file as well, if that works for some of you. I think the issue is with the naming of it. I think that's why it's not able to open.
Shahir, do you have the Spark tutorial that's include the uploaded or no? This no?
Sorry, can you please repeat? I didn't understand.
Spark. There's the Spark tutorial. That one is showing the before
Okay, so that's on the.
reading for.
Let me share those two links.
Okay, please. Okay, thank you.
What is this? What is this? Okay, I've shared it on the all class notes file. Okay, guys, so I think we can leave it here if you don't have any further questions. Once you read it tonight, I think most of you might. I'll upload the video by morning or like by late night, but the notes are available, so you can refer those notes. Try to, if you have still have time, you can try to install Spark and try to launch those Spark shellets and stuff. While you can go over the theoretical stuffs that we discussed, once you have the video with you. So that's fine. Still, if you have any questions, I'll be available because it's my morning in here. So your night I'm available. You can ask me anytime. And yeah, so let's leave it for now over here. Any other questions before we leave? Any doubts? Anything you want to discuss, suggest?
Why there's two books? Are these the same or
No, so these two are different.
I was
This is the definitive guide. It's like a complete book about Hadoop, while the operations that you see off to the left is just for the admins. So for operations, wherein you are interested in just understanding how to troubleshoot, how to see. I think in this operations book also there would be something about Spark. Let's check if there's some troubleshooting steps involved included. This beautiful mouse book. This guy included whole zoo in Hadoop. Okay, maintenance, troubleshooting, happiness. So everything related to the admin's point of view, it's like included in here. I don't think they have included Spark troubleshooting, but you have, I think, Yarn troubleshooting might be there. Schedulers, I think we have already discussed all this. Kerberos is also there, which we'll discuss. Yeah, I don't think they have Spark troubleshooting, but I think they have something like some other troubleshooting things. So you can refer it once you are done with all of this, right? Okay. Any other questions? Okay. So let's just go over those like homework part and submit it before the next class. And also for the guys who haven't submitted their previous HBase homework, I would like request you, it's all for your benefit to submit it to me. And an additional task for those who are more interested in learning about HBase, if you, since you are doing about HBase for now, so you can do it for a little more. So try to get your cluster into an inconsistent state. So that I'm saying this because I want you to get into troubles so that you can understand how to troubleshoot it. Just go over some internet link and see how you can write it in HBase notes. Okay, I think this is for Samia and other people who are more interested in HBase troubleshooting. So try to create an inconsistent cluster. I think you can mess up. Just find the HDFS file associated with your HBase table, and you can delete it or just delete a part of it. So that would mess up your HBase table and make your cluster inconsistent, the HBase cluster inconsistent. Okay, and then figure out how you can solve this. How you can, although it won't be able to recover, but at least just try to run this HBase hbck -repair or something like that. Scenarios, troubleshooting scenarios that people like mostly get into, and you might try to replicate and create those scenarios. Is first of all, it's like inconsistency. There could also be assignment issues. Assignment in terms of the region. So region might be not correctly assigned. So figure out how something like this can happen. Create this on your cluster and then try to fix it. Then there is something like holes, HDFS holes. Okay, so before going with the thing that I just suggested, creation and deleting the files, just try to research internet what can make these three scenarios available for you onto your HBase cluster, and just try to troubleshoot it. It's a little advanced topic. It's an advanced way of understanding this troubleshooting scenario, and we might include it, discuss it after we are done with the basic understanding of all the services and stuff. But if you are still interested right now, because although I think there must be some continuity with the HBase, you guys will be still working on HBase. So just in that, if you don't want to trigger lose that continuity, just they give at least 30 minutes to 40 minutes and try to do this troubleshooting as well. Okay, I leave it with this for now. We meet on Tuesday and discuss the further things. So we are left with a little more into Spark, and then we'll start with the clients, and then probably the same week we'll also start with the other week's topic. I think we are left with some security stuff and some other things. So we'll discuss that in the next class. Good night and goodbye.